All right, you know the drill. It's day 18, or this is our video review from day 18 of Advent of Code back in 2022. And this is this was the simplest problem of this particular stretch. Days 16, 17, and 19 were all extremely difficult, but day 18 was kind of a respite, a little bit of a break in the middle of that. It's a fairly easy problem. All that's happening here is we have 3D coordinates, which represent, cubes. So basically cubes that are, 1 unit by 1 unit by 1 unit, and they're just occupying that space. And so each of these cubes has 6 faces. And so when we consider each face to be, a unit of 1, we want to find 2 different values for the surface area. So in the first part, we're going to find the total surface area, including interior surface area, because our 3D solid could have air pockets of sorts. But then in the second part of the problem, we're going to exclude those. We're only going to look at exterior surface area. So this is actually a pretty straightforward problem. Parsing, no problem. They're all just positive numbers here. So it's just, number, comma, number, comma, number. And we just return a 3 tuple. That part's easy. And then for part 1 of the problem, we just have to loop through each of these items. And the only thing we're storing over the course of our loop, we want to store the different faces that we've already, or I shouldn't say the faces, we should store the different coordinates of the cubes that we've already processed. So we have this hash set of the coordinates we've seen, these 3-dimensional coordinates, and then we also have the count of the number of faces that are showing. So how do we process each individual cube? Well, in the most basic way, each cube contributes 6 faces to our surface area. Each cube has 6 faces, and so we would just increase the face count by 6. However, we have to subtract 2 faces for our total count for each, in each direction we look, where the neighbor actually exists in our previous set. So we have the previous set of all of the different coordinates that we've processed so far, and we can calculate the neighbors of an individual coordinate. And we just want to look at each of those neighbors and say, okay, has this neighbor been seen before? If so, we subtract 2 from our count, because we're subtracting 1 face from the new cube that we're adding, because we have this value of 6, but then we're actually taking 1 of those away if we have a neighbor, and we also have to subtract 1 for the neighbor itself. We counted that neighbor's face towards our surface area, but now we're blocking off that face, so we subtract it from our surface area. So as we have 6 minus 2 times the total count of the neighbors where we've already added that neighbor to our set. That's really all there is to the first part of this problem. We just loop through the different lines and we get our value. Not too hard. The second part, now we want to exclude those interior area. We want to exclude the air pockets, and the way we do that is actually by using a breadth first search. So the key here, theoretically use a depth first search as well, because we're just going to sort of process until we run out of area to look at. But here's how it works. First, we're going to develop a bounding box around our solid. So as we look at our different inputs, we want to keep track of the minimum x, the maximum x, min y, max y, same with the z values. And this allows us to basically put a box, sort of almost the minimum bounding box around our solid, but we just want to, have a little bit of give, have 1 unit free on each side, just so that we don't get sort of stuck and unable to access parts of it. And then we commence our breadth first search. So we're using a sequence, that's a queue for the breadth first search, and then we keep track of a hash set of the locations we visited already. And what happens each time we dequeue the first element in our set is we look at its neighbors. And we want to filter the neighbors, because we don't want to, look at, we don't want to consider a neighbor that we've already visited. We also don't want to consider a neighbor that is not in bounds. So we have these 2 checks on those neighbors. Now we want to partition this set of neighbors based on the criteria of whether or not they are in the cube set. And the cube set, in this case, being the solid, being the all the elements that are part of our shape. Now, for all of those that are not part of the shape, so we're calling this, not lava, we want to put those onto the back of our queue. Those are valid spaces that we want to traverse, and then see what area we can develop from those. We want to continue our search in those directions. Now, for the locations that, or I should make note, we update our queue with that. We also update the visited set. Now we just take the length, the number of neighbors that are part of the solid, that are in the lava, as I describe here, and we just add that to a growing count. So we have this integer value. This is the count. We're keeping track of the number of faces that we have essentially, touched in some way. So we have where we're at one position, we look in a particular direction, and we see another cube that is part of the solid. We increase our count by 1 because it's that's a surface, that's a face, and we're never going to visit that face from any other particular direction. So this works. Once we've expired our queue, we just return the count. It's actually just that simple. Nothing too complicated here. These solutions will give us our answers, and this is a fairly straightforward problem. So, next probably next week, I'll have a new video for days 19 and 20. So make sure to subscribe to the YouTube channel so that you see those, and just also subscribe to the Monday Morning Haskell mailing list. Just so you can stay up to date and get our monthly newsletter. So thank you so much for watching.